Hello and welcome. In this video we are going to begin our discussion on normal distributions. So right now I have a frequency distribution set up here. And what I want to do is I want to create the frequency polygon. So over here I'm going to first draw the axes. Then I'm going to label. So on the bottom these are going to be our scores. So we have 50, 60, 70, 80, and 90. And then we need this axis right here would be our frequency. So I'll just label this as FREQ for frequency. And it looks like it goes from 12 to 70. So we could probably do these in tens. So it would be 10, 20, 30, 40, 50, 60, and then 70. There we go. All right, so the number of scores or number of people who scored a 50, that would be about 15. So again, these are in tens. So that person would be probably right there. And then the number who scored a 60, that was 32. Now let me finish actually label these. So 30, 40, 50, 60, and 70. Okay, so then we had 32 who scored a 60. We had 70 who scored a 70. And then an 80, that was 28 people. And then a 90, we had about 12. Okay, now if this, again, a frequency polygon, then we would connect these with a line. I'm going to just do a dotted line right now. Okay, so there's our frequency polygon for this corresponding distribution. But this type of distribution has a form that we probably are familiar with, which is called a normal distribution. You might have heard it as kind of, what else do we call it? Normal curve, or we can call it a bell curve. This frequency polygon has this type of form to it. So if we were to, instead of making these straight lines, if I kind of made them smooth, it would look like this. Okay, and that was my best attempt at trying to make a nice smooth curve. But you're probably familiar with this. This is what we call a bell curve, or a normal curve. So when we say normal curve, we're just talking about a frequency distribution that has this form to it. So how does a normal curve look like this? Well, it just comes down, it's just the frequency here. Notice that the first and last are very close, and then the next ones, 28 and 32, they're pretty close. And then they start increasing, and in the middle, you'll have your largest, so it's going to form this type of curve. Now, this isn't exactly normal. Okay, there are some characteristics to a normal distribution that this differs a little bit. But one of the biggest things you'll see is that the center is going to be the mean, although the mean's not exactly 70, which is, again, why I'm saying it's not quite normal. But you'll notice that the peak will always be in the center. And these normal curves come in all a bunch of different shapes and sizes. So let's take a look at a couple different ones. And I've put up 3 different normal curves here. Let's just go over some of the characteristics right now. One of the biggest characteristic we have is that the center, the mean, the median, and mode, they're all the same thing. So this point right here, okay, where you have your peak, okay, that's going to be the mode, but it's also the mean and median. So that's our biggest characteristic. Second characteristic is that this vertical line right here cuts the curve in half. So it's symmetric about this vertical line. So that's our second characteristic. And then there's a couple different ones too. But those are the 2 biggest ones, that the mean, median, and mode are all the same, and then it's the center line, and then it cuts the curve in half. Okay, so between these 3 different curves, what's going on here? I've labeled them all to have the same mean, okay, because that's not really the big deal here. But what makes these look different? Now remember, when we were talking about frequency distributions, if you wanted to describe a set, there were different things we needed. One of them would be the measures of central tendency. Spelled measures wrong. Hold on. There you go, that's better. So measures of central tendency, those would be the mean, median, and mode. That's one way we can describe the set, but then we also needed another thing, and that was our measures of dispersion. And when you team these up, they described our sets very well. All right, so the mean, median, and mode are all the same. So our measures of central tendency, all the same thing. But which dispersion are we going to use? And in this one, we're going to be using the standard deviation. Remember, the standard deviation describes how spread out your set is. So, like in our previous example, how spread out our scores are. So, if we're assuming in each one of these three that the mean, median, and mode are all the same, our mu, okay, what must be different? And it's going to be our standard deviation. Now, this again, the standard deviation talks about how spread out something is from the mean. Okay, so notice that if you have your vertical line here, all right, just looking at this one normal curve isn't not going to help too much. But if you compare it to another one, okay, can you see how from the center line how this curve is not that far from the center? Okay, so this is not spread out. So what does that mean in terms of the standard deviation? It's going to have a smaller standard deviation. Now that's relative to other normal curves. So if you're comparing this normal curve to this one over here, then it's going to have a smaller standard deviation because the scores or your frequency is not spread out too much, or your scores aren't spread out too much. Again, you can see the distance from the line to the center here. Now if you come and take a look at the one down here, okay, let's draw a vertical line. All right, now when you draw your arrow from the center, okay, you can kind of see how far we have to go out. All right, this one, it's very spread out. And what that means is it also has a larger standard deviation, again, compared to the previous two normal curves. So here I wrote down a larger standard deviation. So normal distributions are not that mysterious. Normal distributions are just frequency distributions that when you create the frequency polygon or you make a graph of it, it's just going to have this form to it. And it's going to have the qualities where the mean, median, and mode are all about the same, and the mean, median, and mode split the curve right in half. So you have about the same number of people or same number of scores on the left than you did on the right-hand side.